Alright, today we're going to continue our discussion of how we're going to apply synthetic division, and the next step is diving into the fundamental theorem of algebra. We'll start you with an equation like this. It's a cubic equation with four terms, and I factored it for you into x plus 3 times x minus 4 squared, and the question is, how many solutions does it appear to have? Well, pretty obviously you're going to come up with the solutions x equals -3 and x equals 4. If we look a little bit deeper into how we could rewrite this to make it x plus 3 and then actually write out x minus 4 twice because it's squared, you could probably be convinced that the solutions could be this, where you're writing 4 twice. And what happens is that occasionally in these problems you get a solution that can be treated as something called a repeated solution. And in this problem, that's what 4 is going to be, is a repeated solution. We're going to revisit that thought here in a couple minutes, but just kind of a heads up on that idea. The degree of the equation above, meaning the highest exponent, the answer to that is it's 3. And if we count x equals 4 as a repeated solution, the total number of solutions this equation has is 1, 2, 3. So we have 3 total solutions. And that is the main idea behind the fundamental theorem of algebra. It's that if the degree is n, then the number of solutions is n. So in the summary box here, what you can write is that degree equals total number of solutions. So if you have a 5th degree polynomial, you're going to have 5 total solutions. If you have a 3rd degree, you're going to have 3 solutions. Just kind of something that ties into all that we've done this last week and hopefully put some things in your brain. At this point, what I'd like you to do is pause the video and work through this problem using some of the ideas that we have from before. I've provided a graph for you, graph on your calculator to check the accuracy of my work, but I want you to take a glance at this graph and then begin testing zeros on your own. See if you can work your way towards an answer. I will tell you this before you start the problem. X equals 1 is a repeated 0. And when a 0 is repeated, you're actually allowed to use it twice. So be aware of that fact going forward. So again, pause the video at this point and try to work through this problem and get all 5 solutions, including the complex solutions that exist. Alright, so hopefully you solved this thing, and I'm going to quickly run through the work here to make sure that everybody's on the same page. 1, -2, 0, 8, -13, and 6. Certain that I'll make a mistake doing this math. Do my best not to. Alright, so test that first 0 and it comes out. I'm just going to use 1 again because, again, as I said, it's repeated. You have no reason of knowing that currently. That'll come in a few short moments. So we've now reduced this thing to a 4th degree function, which is still not something that we really would care to manage in this situation. So just keep on dividing, keep on working, try to knock this thing down to a cubic function, which we've done. So we've got 0, we've tested 1 twice. The final thing to test based upon our graph is going to be -2. I'm going to test that against 1, 0, -1, excuse me, and 6. -2, 4, 3, -6, and 0. So we've confirmed that the graph is correct and that x equals 1 and -2 are zeros. And the lone thing left to do now is we've got this quadratic here, x squared minus 2x plus 3 equals 0. We've got to solve that. Unfortunately, that's a quadratic formula issue. So as you set this up, or as you set this up already, hopefully, if you obeyed the previous instructions in the video to do this on your own, we'll jump through this pretty quickly. You end up with 4 squared minus 12, which is negative 8. So 2 plus or minus I square root of 8 all over 2. We know the square root of 8 can simplify to 2I root 2. And then all of those are divisible by 2, so your final two zeros, and I'm going to write this out like this on purpose, are going to be 1 plus or minus I root 2. And if I write this as two separate zeros, I'm going to have 1 plus I root 2 and 1 minus I root 2. The reason that I wrote it separately is to help you answer the questions on the next slide, which are going to involve the following. Are there any repeated zeros in the problem? And that's a duh question because I already told you the answer to that. X equals 1 is. What I want you to focus on is what does the graph do at the repeated 0? So if I go back to my graph, if I look, there's the repeated 0. Kind of think to yourself in your own words how you would describe what's happening there at x equals 1 at that repeated 0. And you can also glance at this was the graph of the first problem I gave you, where 4 was the repeated 0. And the language that you would use to describe that, I'll put the formal word on the next term, but on the next page. A lot of people will write changes direction. Some people prefer, the simple language of turns. I've had students in the past, a student actually made up this word. He made up the word parabolates. I'm not exactly sure if that's even a word or not, but it actually defines what happens is at that repeated 0, it kind of comes down in turns. Whereas at the non-repeated zeros, which include -2 here and -3 here, the non-repeated zeros, it just goes through the x-axis. So at the repeated 0, it changes directions, or it turns or parabolates. And at the non-repeated 0, it kind of just intersects the x-axis, so you can fill in the answers to those two questions. And then number 3, as you solve for the rest of the zeros, you got 2 complex zeros, and what you want to analyze is what's special about those complex zeros. Besides the fact that they're imaginary because they're complex, but as you look at these two, a vocabulary word beginning with C should be popping into your brain, and the word that I'm looking for there is conjugates. So the two imaginary solutions are conjugates of each other, which is a really, really important fact to grab onto. So on the next slide and on the other part of your notes, you'll see us formally describe this. Graph behavior near zeros. If x minus k is a factor, that means that x equals k is 0. A fact that you should know really, really well. If it's raised to an odd power, meaning 1, 3, 5, so on and so forth, then the graph will simply cross the x-axis. If x minus k is a factor, again, telling you that x equals k is 0, and it's raised to an even power, then the graph will be, and the word we're looking for there is tangent. If you remember that word from your geometry days and definitions of circles. So it'll be tangent to the x-axis. Again, here's the idea we're looking for. Non-repeated 0 raised to an odd power, it's going to just go through the x-axis. Repeated 0, it's going to change direction, just touch the x-axis, so it's tangent. And then the complex conjugates theorem, if a plus bi is 0, then so is a minus bi. Same thing stands for radicals. If a plus radical b is 0, so is a minus radical b. Finally, how we're going to apply that fact. We're going to now look at working backwards on these questions, meaning I'm going to give you the zeros, and I want you to tell me what the polynomial is that's associated with these. So we're going to change each of these zeros into factors. 4 is a 0 would be x minus 4 is a factor. 1 plus radical 5 is a 0. This is going to be tricky, is x minus 1 plus radical 5. And then we need to include, because of the theorem here about conjugates, If a plus radical b is a 0, then so is a minus radical b. So if 1 plus radical 5 is a 0, so is 1 minus radical 5. So we're going to need to include another factor for that. When you write out your factors, this is always a subtraction sign. That's going to be important down the road. A lot of these problems will have just simple factors, and you would simply FOIL some stuff out and distribute, and you have your answer. When you get these radicals in there, it tends to get a little bit tricky, so we'll deal with that first. You're going to want to first distribute the negative sign into those separate parentheses. So it's going to be x minus 1 minus the square root of 5 times x minus 1 plus the square root of 5. My suggestion for you in terms of multiplying this out is to create a grouping situation where you put the x minus 1s together and then do FOIL. So it'd be x minus 1 times x minus 1, which is x minus 1 squared, and it'll be x minus 1 times positive square root of 5. Don't distribute that, just leave it. And then you go the other way, it'll be negative square root of 5 times x minus 1, and it will be negative square root of 5 times positive square root of 5, which is just negative 5. What happens in this situation is your middle terms cancel out, which is why grouping it like this makes sense. Cancel and cancel. So this is simply x minus 1 squared minus 5. When you multiply this out and FOIL it out, you should get x squared minus 2x plus 1 minus 5, or x squared minus 2x minus 4. So that is simply these two things multiplied together. That can be a little bit tricky, and if that grouping idea is beyond you, you can simply at this stage in a problem just take x and multiply it by x, and then by negative 1, and then by radical 5, and then take negative 1 and do the same thing, and then take negative square root of 5 and do the same thing. It's a lot more distributing, however it does lead to the right answer. And then don't forget about this guy. You got to bring x minus 4 all the way down, and multiply x minus 4 times those terms, so a binomial times a trinomial, x cubed minus 2x squared, I'm going to do this algebra pretty quickly, minus 4x squared plus 8x and plus 16, I think, x cubed minus 6x squared plus 4x plus 16 looks like the right answer to me. So that is what your polynomial function is equal to based on being given those zeros. Okay, so again, keys to the problem: if you're given 1 plus square root of 5, 1 minus square root of 5 has to be on there. You're going to do a little bit of FOILing here, which can be tricky. Just know that a lot of stuff's going to cancel out in the end, and then your polynomial will always have real and rational coefficients, and the leading coefficient is going to be 1 because that's the way we've set up the problem. Run back through this video if you need to catch up on some finer points, and good luck on your homework assignment and the stuff you have to do tomorrow.